I think whether it comes to, look at the Egyptian history, how advanced the pharaohs were, right? I mean, you look at the the Muslim history, how advanced Muslims were in the past, and then when I look at where we are today, it's kind of, in a way, it drives me really. I want us as whether it's the Islamic world or the Egyptian world, really to come up to where we were. It's AhmedEHassan. So I originally grew up in Egypt, okay, did all the way up to my high school there. And then after that, I immigrated to Canada, did my undergraduate at the University of Waterloo. And then after that, worked a little bit in the States for IBM research. And then came back to Canada, did my master's degree. After that, worked for BlackBerry for, 5-6 years.
I think the experience of working with him is always as something new. That basically we start like the earlier guy mentioned, we are mining software repositories. So although there's a lot of things have been mined, and he can always help us to come up with new ideas and help us to guide us through how to mine the important stuff out of it to make some impact. I think that's a very exciting experience.
Well, the great thing about being with Professor Hassan is that as a student, when you were in a dead end and don't know exactly what to do, you always feel backed up. So you go there, you speak with him, he's gonna have ideas, he's gonna know what to do. So you really feel, backed up and safe as a student.
Eventually after that, became a faculty member at University of Victoria, and then eventually moved back to Ontario, Canada and Ontario, at Queen's University, where I actually became a professor, and I have been a professor since then at University of Queen's University. I have one sibling, so a younger brother, okay, and my mom and my dad. So my mom was a translator in the Egyptian TV, okay, and my dad was a businessman. So early on in our career, my dad passed away, so my mom kind of raised us, myself and my brother. And then at some moment in our career, my mom decided, it's very important for her to give us the opportunity to actually go overseas and kind of gain international education. So she kind of pushed her career, to really try to come here, which kind of was a big challenge for her, because she comes to Canada where, she's a translator of English to Arabic, which nobody really needs in Canada, but she really pushed her, her career for us to come here, and to actually get better opportunities. So that's kind of, the before Canada. And then when I came to Canada, I came to University of Waterloo, did my undergrad here, and then after that, after graduating, I actually went to work for IBM Research. So IBM Research, Ahmed, which is in San Jose, so it's in Silicon Valley. So I worked there for a bit, but then when I was there, I recognized that really it's very important to have, a high degree, right? An advanced degree, because actually my manager told me like, you're good, but without a PhD and so on, you won't really be able to lead research projects and push yourself to the next level. So right now,
Ahmed is a very funny, nice person. It's a nice person to work with. I think the quality that I appreciate the most is how he can think out of the box. Like a lot of times you're kind of stuck. You don't really know what to do, and he always has like some very interesting idea coming kind of out of nowhere. So that is a very nice quality that he has, the one that I appreciate the most. And he's a very smart and funny guy too. So we always had a very nice relationship overall.
من آقای دکتر حسن رو سال‌هاست که تحقیق و پژوهششون رو دنبال می‌کنم و امروز به عنوان دانشجوی دکترای ایشون بسیار خوشحال هستم که ایشون معلم من هستن در حال حاضر و ایشون نقش بسیار بزرگی داشتن در پژوهش بنده و همیشه من رو حمایت و پشتیبانی کردن و من از اینکه در آزمایشگاه ایشون مشغول به کار هستم در حال حاضر بسیار خوشحال هستم.
So I think what the big thing for me. So I had one of my uncles actually, my uncle and my aunt, they brought me a computer, right? And that's in the old days. So it was like an XT, which is one of the early kind of Intel machines, a big machine, right? And they brought it to me. They gave me them as a gift, and I started playing with it and tinkering with it, right? And as I started working more and more with computers, I started to realize, I enjoy doing that kind of stuff, right? And I actually started realizing I'm good at it, right? And starting to realize as well the importance of going through the manual and reading all these little things. Because in the past, it's a very different world of computers today, where a lot of time people don't. They just comes in with everything. The software is everything there, right? But in the old days, you just got a piece of hardware, and you got really the manual of all the low-level things that it does. And there was no there was no Google, there was no way to download stuff, right? So you kind of had to read around and try, to solve this problem, I need to do this or this. Some of them might even require, actually going in and changing some of the, the little, what do you call them, switches on the hardware, right? So actually make it run slower or faster, right? So that was a very different world. So you kind of start having a deeper understanding of the computing all the way from the bottom, all the way to the top of the stack. So it was that kind of deeper understanding, and it's very logical. Computers are very logical, which is one of the nice things about them, right? So because it's very logical and it's kind of very mathematical, and I originally enjoyed mathematics as well, it was kind of a smooth transition in there. And I'm very fortunate because in the last 20 years there was just so many big jumps, right? The internet happening, AI happening, ChatGPT happening. And every one of these jumps really has taken the whole world to the next level, right?
Well, Professor Hassan never rests. He's always chasing new ideas and new areas. So even after all this success, he's still, looking for new fields to explore, new ideas. He never stops. So that's great as well.
First, when we started, was open source, and that's still continuing, is how do you make sure that these software systems are actually, not vulnerable and are trustworthy. And now as we move into AI, how do you really make sure that the software that is produced is trustworthy and safe? In particular, when it comes to AI being inside the software systems, because AI in general is not guaranteed to produce the same results every time. So there's a lot of that randomness in it. And how do you actually guarantee that at the end you produce a software system that's safe? Now, in the past 5 years, the idea was we build the software systems and then we put a band-aid, a layer around it to make sure that they're trustworthiness. Now, more and more, as we see these big language models like ChatGPT and so on, these systems are now becoming more and more in the core of our software systems, and now they're becoming extremely more capable.
As you might know, like he was like one of the creator of the mining software repository. So before he was already started mining all different types of software artifacts, either it's a code or some like more like discussions or some other like app stores or other stuff. So it's always he's always been looking at what's the new things in the software engineering and trying to get a deeper understanding out of it.
Kind of what we work on is this, you can think of it as kind of Amazon for computer science people. So when you go to Amazon and you buy a book, and then Amazon people tell you, oh, people who bought this book as well. Well, imagine that idea now replicated for software development. So as software developers are working on these very large and complex projects, there's a lot of activities that they're doing. And some of these activities are done by them, some of them are done by their peers. And there's so much data that's being collected. So the idea here is now, for example, when developer changes a file, we can say, people in the past that changed this file, change this file as well. So probably you want to change that file, otherwise you can introduce a bug, okay? So very similar kind of how Amazon says people buy this, buy that, right? So that's kind of that general idea, that core of that idea of collecting all that data as developers and large teams are working on a project has become a very successful area of research across the world. A lot of companies, whether it's Microsoft, Google, Amazon, all of them now actually have integrated that in their whole kind of development pipelines. It's making them much more efficient. It's improving the quality of their software. And as of late as well, a lot of that technology is now being used and sold as products. For example, when you look at something like very popular right now is GitHub and, for example, Copilot, which are some of the very fancy things out there today.
It's understanding right, which is driven by developers and what the rights is. First, you solve the knack, and it's driven by domain and context. You need humans and agents, so it's a continuous learning.
And CPUs and GPUs, the way computer developers talk to them is they program stuff in like languages like C or Java. That eventually becomes like assembly. And then that actually is how we talked was the low-level hardware was that, right? Well, a large language model is almost a different type of compute unit. And now instead of having all this unnatural programming languages, we're talking them that eventually get translated to another unnatural assembly and bytecode and binary. You actually can just talk to them in English or whatever language, a natural language, and go back and forth, right? So the potential is really huge here because we're really simplifying the ability to actually interact with the computer. So it's changing not only how we talk to computers, but as well the accessibility to people. So you used to have you need to do very specific training to be a software developer. The question right now is that type of training and the complexity of the training could drop for a lot of tasks. Doesn't mean that software development is going to disappear, but it means there's a good amount of tasks that you might need to bring in, your expert friend to code it for you or write a little script for you. These type of tasks now can be actually automated with large language models. So we believe it's opening a lot of potential, but actually the bigger area of my focus actually is like software engineering in general, which is really how we build software and what it really means to have software, right? And for the longest time, the idea is software means you have a piece of code, and the piece of code is running on a physical piece of hardware like a CPU or a GPU, right? Well, now with large language models, the question right now is maybe you don't need at all code anymore, right? And you look at something like GPT and you tell it, you are now a browser, and I want you to behave as a browser, and I want you to do these things for me, and it will respond. I want you to go get a web page for me.
Human work.
What I've been working on is this idea of mining software repositories. So looking at all the data that's available in repositories and trying to understand how we can use them to make better software or make it more efficiently with less costs. Now, what's moving next, really the two big challenges is first is today with all of the innovations in AI, which is something we've been using as part of the MSR, we're recognizing that even the definition of what software is totally changing. Software might no longer be just a piece of code that's actually running on a hardware compute unit, right? Instead, actually, it might be instructions that are running on side of these very fancy, large language models like the ones that are inside of, ChatGPT and so on. Which means we really need to rethink what software engineering is, what are the challenges about doing that type of work, and how we can make sure that these type of systems are trustworthy and safe for people to use them. So that's one of the biggest challenges moving forward.
MSR was an area, a research area that Professor Hassan kind of helped to inaugurate and to start. And basically, the idea is that you mine or you explore empirical data from software engineering to understand problems and to come up with solutions. So this started actually because of during this boom of data science and data. So platforms such as GitHub, Git started to generate a lot of data, and Professor Hassan saw the opportunity to explore this data to come up with more fundamental and better grounded theories and explanation for software engineering phenomena.
I think a big part of growing this whole MSR community across the world is actually communicating, right? And really convincing managers or funding agencies around the world of the importance of actually looking at this type of data and the automation around it. And I wouldn't be able to do that if I'm kind of an introvert person that doesn't want to talk to people, right? So it's very important to have that. You know, communication really is a key thing today for any type of scientist. You cannot just only do your research in the little lab and publish it and assume, okay, if you don't understand it, tough luck, but it's really good stuff. That's not how it works, right? The communication, the sales thing is as important and actually as the hardcore science that happens. An ability to really bring people together is actually one of the things that really attract me to computer, in particular to software engineering, because software engineers are, how do you bring lots of people together to build something cool, something innovative, right? So I guess my interest kind of drove from first, okay, this is really cool. I'm able to do a lot of interesting things with it. But now, with the power of many people working together, the complexity of managing these people, because software engineering not only brings the computer technical aspects, but the managerial aspects, the people aspects, all of them kind of mixed together, working together to actually produce something. And that thing actually has an impact that's very visible on society. So I would say it wasn't just like an immediate, okay, I like this, okay, oh, I like computers, they're easy, they're simple. I tell them to do something, they'll do it for me. But then realizing that they're actually like an equalizer and a power, you know, an amplifier if a lot of people working out together. So it was a combination of both that got me to really say, this is the field I want to be in. Because, you know, I could have been just a pure computer scientist, which are essential, are needed. But as well, I think the software engineers are really the ones that take different technologies, bring them together to the next stage and connect them into society.
ایشون نقش بسیار مهمی داشتن هم در حوزه نرم افزار و هم در حوزه هوش مصنوعی و به عنوان مثال ایشون فیلد ماینینگ سافر ریپوزیتوری رو ایجاد کردن و از اولین محققی بودن که اصلا به این موضوع فکر کردن و از این نقطه نظر یک دستاورد بزرگ به حساب میاد هم برای جامعه نرم افزار و هم جامعه هوش مصنوعی در سطح کل دنیا.
Yeah, so Ahmed actually created the MSR, Mining Software Repositories area, and it started as a workshop, and now it's like a fundamental research area in software engineering. So that's amazing.
And it didn't exist before.
It didn't exist before. It was his creation, basically. Yeah. He just saw an opportunity there because people were basically just guessing, right? And with mining software repositories, the idea is you get empirical evidence for stuff by mining history.
I think what we have been doing has always been supported and people have been convinced of value. I would say the only thing was just being able to demonstrate more, because we've seen a lot of value already early, but you know, as the size of my team was small, I couldn't really demonstrate wider impact, right? So originally we just started by demonstrating the value when you're working on a software project. And then as the team grew, we started showing as well the value when the project is actually in the field. So using data from a project when it started, like software when it's actually executing. So we've kind of, as we grew as a team, like lab grew, being able to demonstrate that this is not like a one-off thing. It's not only to help with a very specific task. It's actually demonstrating that the vision we have is a very general vision that can help with software development and software engineering throughout its life cycle, whether it's requirements, design, you know, architecture, design, development, testing, maintenance, evolution. The whole end-to-end cycle, there's a value in there. So I would say the biggest focus has been to just demonstrate this is not just a one-off idea, but it's actually a wide impact idea.
So software engineering in general, really, and the way we make software had changed drastically over the last few decades, right? In particular, we have seen the big rise of open source, right? And now we have these software systems that are built from thousands and thousands of components. And now the safety of these components and the impact on their safety and their quality on the overall software that you're using as an end user is a very big important. That's why today things like software vulnerability is becoming a very big topic and a lot of people are talking on. So that's one aspect. The other aspect is, as we see, foundational models, large language models, and AI being integrated more and more into software engineering, some of the challenges now about making sure that these AI, that when they're integrated, actually are safe is one of the next big challenges as well. So really about the vulnerability that are in the open source software systems and the trustworthiness and the safety of these large AI models are two of the next big challenges when it comes to software engineering, because we're moving to this world where instead of having you working on a project with human teammates, you really have these AI teammates. And now these AI teammates, you need to raise them, you need to understand their limitations, and how you can do that, how you can rethink the whole software engineering pipeline and processes to integrate human and AI working together is some of the big challenges we're facing moving forward.
Okay, I guess some of my most my biggest achievements, I would say first is I was the youngest industrial research chair in Canada. So industrial research chairs are chairs that are funded by the government and industry to work on an area of research. So that was my industrial research chair was BlackBerry. So that was one of the achievements. Second off, I am an IEEE fellow. Okay.
What's happening?
So 0.02% of all IEEE members, which there's 400,000 of them in the world. Okay, so I'm an IEEE fellow. I'm as well an ACM fellow, which is basically these are the two highest affiliations in computing, IEEE and ACM fellow. So I'm both of these. I'm as well recognized by IEEE. Actually Computer Society for creating the field of mining software repository. So there's an award that I was the first inaugural winner of it, which is the New Direction Award. So the New Direction Award recognizes people that have actually created new directions that have kind of impacted the field, right? So I'm a recipient of that award as well. Yeah, that's a very quick summary of, I guess, the big highlights.
I'm sure this prize comes in the recognition of the great contributions that Professor Hassan gave to the whole area of software engineering, honestly, not only mining software repositories. Professor Hassan, with mining repositories, touched every single aspect of software engineering, so it's not surprising to me that they're, giving them this prize.
باعث خوشحالیه. من به خودم به عنوان دانشجوی ایشون واقعا باعث افتخار منه که مربی و معلم من تونسته یه همچین جایزه معتبری رو ببره.
Well, it's no surprise really. Like, he has been an amazing researcher. Just the number of people that came out of SAIL and became professors in Canada in software engineering is just crazy, right? So it is, I'm very happy for him, but it's no surprise. Like, he definitely deserves that.
Until I was, contacted about being, shortlisted for it. And then when I started actually reading about the prize and trying to understand, the rationale for creating it, I actually discovered that this is a really important initiative, right? And it's an extremely important direction that we need to move in the Islamic world to really kind of push the, Islamic scientists and the Islamic world to kind of go back to kind of being a leadership in sciences and technology. Looking back in the past, the Islamic world and Islamic society was really the forefront of innovation in the world, and now we've kind of taken the second seat, right? So these prizes and actually the way they help push our whole community and push recognition for our top scientists are very important, in that direction, to really bring in and shine on the light about a lot of the strong innovations that are happening in the Islamic world. So I think so one of the important values that the Mustafa Prize brings is that it actually has a much global perspective on sciences and innovation, and especially for example, computer science being a young field, a lot of time is not that well recognized in all of these very prestigious awards, right? So, for example, computer science can never win a Nobel Prize, right? They don't exist, right? Because it's kind of only focusing on the classical sciences. But today the world is much more than the classical old sciences. So there's much more sciences and much more new disciplines coming in. So I think this is one of the biggest strengths of the Mustafa Prize is actually it has a much more open view on science and the impact of the different sciences. Getting these type of prizes, which I have much more freedom in what I want to explore, really enable me and my team to really go to the next level, to really explore things that I know that if I put that in a funding grant, it will 100% be rejected. Because quite frankly, if I were to read it myself, I have a good chance to reject it, right? But now I'm able to put my kind of own funding and actually pursue this. And then that's the kind of thing that really opens up new doors for my field and for my students and for actually the whole computing science and society. So the cash part of the prize is a very important part in really enabling us to do much higher risk research that wouldn't be possible in the classical funding structures that exist today. I think my recommendation comes down to it's very important to recognize top researchers, and it's important the prizes like the Mustafa Prize, but as well it's important as well to recognize as well the mid-career and the early career researchers as well. A lot of times these are the ones that have really a lot more energy than us old guys, right? So it's really important to invest as well in the young researchers. So I think that's having prizes that not only are lifetime prizes, but as well early career and mid-career prizes, I think are important. So that will be one. Second as well, which I think the Mustafa Prize is very good at as well, is creating a collaborative network that enables cross-pollination across fields. Because today, this is one of the biggest challenges we're having when it comes to sciences. Every science and every field has become so sophisticated and so complex, there's very little cross-pollination happening. And it is that cross-pollination that really brings two different ideas, brings them together, and does these big leaps in science and evolution.
So I think the field of MSR would never be what it is without Professor Hassan. He really thought this through. He really came up with, a way of organizing the knowledge and seeing things in a very concise way and very precise way of explaining MSR. If you have the opportunity or the chance to be in one of his MSR classes, you will definitely see this. He one of the few people that, because there is a lot to talk about in MSR, right? And he was able to put everything together in a very concise and nice way that it's explainable to people. So, yeah.
Would you say he's inspirational?
He's very inspirational, for sure.
Absolutely. Ahmed is very, very influential in his field. I think everyone that does software engineering research is aware of his work. And it's just very influential because he worked on different aspects of software engineering. He touched different parts of it, so he is a well-known researcher for sure.
Back to where I started. Right? So in Egypt, basically it's only my mom that's kind of taking care of us, right? So we have very limited income, right? So trying to go from there all the way to Waterloo, right? And the cost of being in a university is kind of prohibitive, right? So now, fortunately, Waterloo has the co-op program, so internship program, right? So literally it was like work one term, make enough money, save to spend for the next term for your education and so on, right? So it was 4 terms work, 4 terms, learning at the university, 4 terms, 4 months, right? So every 4 months, different city, different environment, right? So the advice I give to students and young researchers is you have to be very intelligent how about you approach risk. You don't want to go all the way, you want to go middle, right? You have to kind of balance it based on the challenges you're facing in your career and your research.